Good afternoon, everyone. Welcome to a webinar on unlocking growth with location intelligence and optimize distribution networks and identify serviceable areas. I am Siddharth Jain. I take care of the marketing operations at Lepton Software. And let me start off with a basic brief as to what all topics that we'll be covering in during this webinar. First off, we'll be covering Lepton's overview, what is location intelligence, why location intelligence matters in today's market, what are the common operational challenges location intelligence solves, understanding the technical aspects of location intelligence, how smart market and Google Maps platform integration becomes an engine that actually helps all the businesses to expand to the right set of areas, optimize distribution and identify serviceable areas. Then we move on to live demos and real world use cases. Follow that finally with a Q&A session wherein you can pitch in your questions around location intelligence and the use cases that we've discussed today. Let me start off with giving a brief introduction about Mr. Manish Gupta. He's the business head of location intelligence at Lepton Software. And the topics that he'll be covering today will be Lepton's overview, what is location intelligence, why location matters today, and what are the common operational challenges. Over to you, Manish.
Siddharth, hello everyone, a very warm welcome and thank you for joining us today. Again, my name is Manish. I head business for location intelligence here at Lepton. I'm thrilled to be co-hosting this webinar on unlocking growth with location intelligence along with my colleague Umang Saraf. Quickly, before we jumpstart, I would like to give you a quick overview about our company. For those who are new at Lepton Software, we are a prominent figure in the universe of location intelligence, map data, and geospatial consulting. With over 30 years of experience, we have built expertise across a wide array of industries, including telecom, FMCG, transportation, government, retail, IT, automotive, and many more. Slide, please. Just to quickly look at Lepton Software at numbers, we are a 30-year-old company completely into GIS. We are present in 5 different countries. We have 500 plus experts sitting out of various offices. Our head office is in Gurgaon. These 500 people primarily consist of a lot of engineers, GIS engineers, and developers as well. And we understand that, we've been building solutions since very long, and these solutions are implemented in organizations' day-to-day operations where they need 24/7 support. So we always offer, on these solutions, we offer 27 support. So as I said, we've been present in 5 different countries. Out of these 5 different countries, we are able to curate data for at least 25 plus countries. We have mapped up to 150 million kilometer roads. We have 1,000 plus subscriber active on our platforms. And let's deep dive on, company offerings, what kind of products that we offer. Quickly running through our offerings, which comes under the location intelligence platform. The first comes the Smart Market platform. It is a visualization analytics tool. It comprises of smart data. Now, smart data is various data sets that Lepton has curated over the years, which has all location as a part to it. Then we also understand that a lot of organization doesn't have capabilities to ingest the raw data at their end. So we have created those APIs, custom APIs for them. At the same time, we also go out to the customer where they only know they have various challenges or pain points, and we create bespoke solutions for them. At the same time, we are one of the largest and the oldest Google Maps reseller in the market, not just in India. We are one of the largest reseller for Asia Pacific. So we not just sell Google Maps vanilla enterprise APIs, we are also authorized reseller for mobility solutions and for Google Earth Engine and turn by turn for 2-wheelers. Slide, please, Siddharth. That you know a bit about Lepton and our solutions, let's clearly define what exactly is location intelligence. At its heart, LI is about taking actionable insight from geospatial data. It's about going beyond just vanilla maps. It involves combination of various data sets that includes demographics data, transactional data from your sales, behavioral patterns, point of interest like competitor location or public amenities, and even environmental data such as terrain or weather patterns. Ultimately, the location intelligence help you understand the where and why behind your business. Where are your customers? Where are your opportunities? Where are these risks, and why these patterns are emerging? Why the location intelligence gaining so much traction now? We are witnessing a fundamental shift from traditional gut feel decision making to a more driven data approach. The geospatial analytics market is already substantial and valued at over 18.8 billion, and it is rapidly expanding. LI delivers tangible impacts across a multitude of industries. And importantly, being an early adopter of LI provides a significant competitive edge in understanding markets and optimizing operations and serving customer better. To make it more concrete, let's look at some of the challenges that location intelligence help to solve. First up, inefficient routing and high fuel cost. This is a big one, and it's when your delivery trucks or field staff aren't taking the smartest or the shortest route. Imagine your drivers taking longer paths, which means they are driving extra miles or burning more fuels or spending more time on the road when they don't need to. And that happens when there is a sudden traffic jam or an unexpected closure on the road or even a diversion, or even if there is a bad weather. If your system can't react quickly to these challenges, your team gets stuck and deliverables get delayed. The second is lack of real-time fleet visibility. Basically, not knowing where your vehicles or people are right now. This means you may have to trouble tracking if a truck is running late or if a driver has gone off the course, off the road. And if you don't know where they are, you can't just give your customer accurate ETAs. Think about a customer, calling to ask where my package is, and you can't even give them a confident answer because you can't track your driver and there are no ETAs. The third, inefficient service planning. Insufficient service area planning. This is about how you decide areas your business will serve. Often these are fixed delivery zones. Traditionally, companies have marked lines that are drawn on the map, which rarely change. But what if the demand shift or a new neighborhood pops up? This means you are missing out on the busy or high demand areas because they are just outside your old zone, and you're not sending too many resources to quite low potential zones. For instance, a food delivery service might be overstaffed in a busy business district on weekends, while a newly popular residential area aren't just getting enough coverage. Believe me, these are just the initial hurdles. Let's look at a few more challenges. The fourth one is inaccurate site selection for warehouses and hubs. Sometimes decisions are just made because the location seems close on the map without really considering, things like accurate traffic flow, whether big trucks can easily get in, and the type of terrain, or even if it's a flood-prone area. You get this wrong, you end up with much higher cost for the final leg of delivery, the last mile, and of course, the delayed deliveries, of course. For example, opening a new distribution hub near a highway exit. I know it sounds very great, but if that exit is gridlock every afternoon, it's a bad choice. On the fifth position, we have unpredictable demand and poor territory management. This is about knowing where your customers are and how to divide work among your team members. Often, sales and delivery territories are drawn up based on the old information or a traditional spreadsheets. Or even we have seen there are traditional companies who've been creating these sales territory based on the pin codes. Imagine a company selling a consumer goods where sale territories are still based on the outdated city boundaries, completely missing out the booming new suburbs, which means there are some team members which may get overloaded and some may not have sufficient business coming in. Now, the sixth is exposure to the supply chain risk. The whole supply chain risk can be surprisingly fragile. If there is no backup plan when things go wrong, like unexpected traffic jams, sudden diversions, or even strikes, your operation can grind to a halt. Now let's look at two more critical areas where location intelligence can make a huge difference. And after then I will hand it over to Umang to give you the line table. So at the seventh position, we have last mile delivery challenges. The final step of getting the product to the consumer's doorstep is often the trickiest, and there are a lot of companies still trying to solve it, and it can become very, very expensive. Now you can have really high cost because drivers are zigzagging across town insufficiently, and you're not using the local micro fulfillment spots efficiently. Think of delivering packages to 3 houses which are on the same street, but making 3 separate deliveries because your backend is not good enough to group them. And finally, 8, not the last, the rising pressure of sustainability and compliance. Now, we understand that there are a lot of businesses which are under more pressure than ever to be eco-friendly and meet the regulations. It is challenged to plan routes for EV vehicles, considering the range and the charging station locations. So please understand that whenever these EV charging vehicles are there on road, they have certain range, and they have to ensure that the path that they are following to deliver the packages, there should be EV charging installed, so that if they have to stop in between, they should plan their. So for example, a company who wants to switch to electric vans, but their current routes are too long for a battery life, they don't know how and where to best install these charging infrastructure. To take the deeper into technical aspects and to our smart market platform, I would like to hand it over to Umang, who will take you through. Thank you so much.
Thank you, Manish. Hi, everyone. First of all, I'd like to thank everyone for joining this session. My name is Umang Saraf, and I'm product manager here at Innovation Labs. My journey in geospatial intelligence started almost, I think, 6-7 years ago when I first took a class in college around GIS. And for the past 3-4 years, I've been heavily involved at Lepton Software at building this product called Smart Market, which is a location intelligence product. Today, the flow I'd be following is, Manish has already gone over a lot of use cases, and he's also gone over what is the meaning of location intelligence. So those slides might be a bit repetitive, but then I'll be then moving on to the live demo. I'll be showing the Smart Market platform, showing what is the capabilities of the platform. So and then finally, of course, we will end with some Q&A and also some case studies, how our previous customers have used the platform. I think Siddharth also mentioned initially, there is a QA channel going on. So during the demo, if you have any questions, please feel to fire them. I try to address it during the demo. And also, if you'd like to see something specific, something I miss out, do write it on the Q&A and I'll try to see if it's possible to show today or not. Siddharth, you can move on to the next slide.
Absolutely.
Sure. Right. So what is location intelligence? Location intelligence, like the name says, it is driving intelligence from location or geospatial data. Now, what might be geospatial data? So every day we use maps, and on maps, we see a lot of things. We see point of interest that might be a friend's house or a shopping mall or somewhere that we need to navigate to. We have the roads that help us to navigate to those points of interest. We have different boundaries. We might type a postal code or a city's name and the boundaries comes on Google Maps. So these are all different geospatial data sets that are available, the points, the polygons, the road network. And together in our daily life, they help us in simple things like navigating or understanding where traffic is high or understanding what might be the ETA to a certain place. But it can help you do more at an enterprise or at a business level. It can actually help you to drive much more deeper insights, such as answer questions like, where do I open my next store? Or how do I optimize my delivery or my logistics that I reach maximum number of people in a single day? So this is what location intelligence is. It is driving valuable insights from location-based data. Right. So why is it critical? Why do we need it? First is, like with location data, it's not simple. It's not something you can go and visualize on a spreadsheet or traditional business intelligence tools. Let's say I want to see my current network of stores and I also want to see the competition. I am a bank and I want to see where I am located and where my competition is located. Those things can't be done on an Excel. So that's where the first visualization layer comes in, where I can visualize my data, my competition's data, my customers' data. And just by visualization, also, it's so powerful that you can drive a lot of insights. Second is post visualization, you want to analyze. Let's say that I have all my a data set of all my stores, and then I have population overlaid on top of it. I have income laid on top of over it. I want to analyze why certain stores are performing poor. Maybe it can be the population is low or the income bracket doesn't match the type of products that my stores offer. So that is the analysis layer. Once you analyze, then we move more into the optimization part. It's I have identified areas where I'm not currently present, and these are the areas I should put up my next stores. These are my serviceable areas. If I'm a food delivery company like Domino's, I define this is my serviceable area. This is a 30-minute catchment in which I can service. And then finally, on top of it, with new things with AI, there can also be prediction. So prediction is things like if I am opening, I've identified a new place where I should open my store. What would be the revenue out of it? What is the potential revenue that I will get? We can predict how demand would be shifting over time. If I want to create a 5-year plan or a 10-year plan, really understand where population would be moving, where new infrastructure would be coming. All of that comes into prediction models. And also predicting risk. There's one use case that we have for insurance, trying to predict where natural disasters are more likely to happen, and this prediction models helps insurance companies to adjust their premium rates accordingly. So then it's a whole pattern from visualizing, then analyzing, then using those analysis results to optimize, and finally have a prediction layer on top. Right. So like we mentioned, for to drive intelligence, the data layer is really important. The location data layer is really important, and that's where our platform Smart Markets comes in. And like Manish was mentioning earlier, we work really closely with Google Maps, which allows us to enrich our data, our platform's data. So just talking about how powerful Google Maps is, as we all know, it helps us route on a daily basis. It has real-time traffic data, which becomes really, really important in the logistics industry or in the quick commerce industry. It has highly accurate addresses. It has addresses of more than 250 million POIs mapped out within the country. So this Google Maps data is something that powers our smart market, and together they help businesses to grow. So location data is constantly changing. That's where Google Maps really differentiates itself from others. Every day a new point of interest might come in, a new restaurant might come in. Every day, someday, a new road might be built by the local agencies, which enables better routing, or a new road gets closed, or traffic increases in some areas. So that's where Google Maps really differentiates itself in a constantly changing world. Google Maps is able to adapt with real-time data, and the power of it is that it's not just available in one country, it's available almost across the whole globe, which allows our smart market platform to also function across the globe, be it India, be it Africa, the Middle East, or Europe. Everywhere, this platform, in collaboration with Google and the richness of Google data, can help businesses drive insights. What are some like key capabilities of smart market and use cases? Something we've spoken about constantly. So one is just how I was talking about, even visualization is a really powerful mechanism in which we can use it. Let's say you're an online company, purely online, and you have customer addresses where you deliver. These customer addresses using our platform can be actually converted into latitude, longitude, and visualized on a map, helping you understand what are those demand clusters where actually your customers are present. You can also understand what are those underserved zones. Maybe then you can have targeted advertising in those underserved zones. Where there is high demand, maybe eventually if you want to move into the retail space, in the offline space, you know where to open the store, you know where your customers are present. And it's the best thing about location intelligence is that it doesn't work in silos. It is a combination of multiple data points together. So you have your customer data, you can overlay other data points that we bring in, such as location of schools, locations of malls, locations of restaurants, workplace. You can get demographics overlaid on top of it to maybe understand that if there is a zone which is underserved but the population is high, it might help you answer why am I not doing well there, or shall I be doing well there. And then there are clustering techniques on top of it, which helps you to define different clusters. So this comes in the realm of unsupervised learning, where if you want to define, just have different clustering for different types of customers, and this can go into what type of product do I serve where. So this comes into the clustering. Use cases, Manish already went over it, but I'll just go over it again. Logistics, main use cases in location intelligence is route optimization, which is really powerful. How do I plan my route throughout the day? How do I cover maximum number of stops with minimum number of vehicles? Telecom, it's big. We might not think, but even in telecom, smart market is very powerful. At a high level planning, where do I expand my business? Be it FWA, FTTX, where should I roll out 5G? Where should I roll out 4G? Answering these questions. And then finally, retail and QSR, which is our biggest, like their brick and mortar. These guys, for retail and QSR, this becomes really important because the investment is high. Every time you open a store or a restaurant, you're investing millions of dollars in it. So it's important to have data backed decisions before you get into such a decision. New site selection, basically, where do I open my next store? And how do you use this platform? I'll go into it, but you're basically trying to simulate. You're building simulation engines. You're trying to, one use case that we've seen FMCG companies doing is how do we analyze the impact of outlets in warehouse? If I put a new warehouse, where should I put it? How do I make sure that all my outlets are tagged to the closest warehouse? So we can do simulations. Some other simulations that people have previously done on our platform is, if I open a new store, does it cannibalize my other stores or not? Let's say I'm a Starbucks or a Subway, which is heavily present across the city. When I open a new Starbucks, is it that it would take business from other Starbucks or not? So those are what if simulation engines. What would happen if I open a new Starbucks in this place? Maybe it will do well, but also it might just drive business away from your other existing stores. So these simulations are really important to run before you make these decisions. And one more simulation, again, that I spoke earlier is prediction. That is also comes under the simulation. That what would be my sale today? What would be my sale in the next 1 year? What would be my sale in the next 2 years? Customers, we have customers across all industries, be it e-pharma, be it retail, electronics, Ather, it's a two-wheeler electric company, Varun Beverages, biggest bottlers of Pepsi in India. They have over 20 million outlets that they serve. Mahindra Tractors, Birla Opus and Ultratech, both are in the construction material. VI, which is telecom, Indian Oil, it's petroleum. Health Assure, again, it comes under medical, it's a insurance company. So customers across all industries. And I'll just let everyone just maybe take a look for a minute what our customers are. And if you have any questions, what are the exact, if you relate to any of these customers or you're in the same industry as any of these customers, feel free to ask a question in the QA box, and later I can answer how exactly they are using our solutions to make better decisions. Cool. Thank you. Right. So I'll, yep. I will
can
dive.
start off with demo.
Yep. So just confirm once my screen's visible.
It's visible, Umang.
It's visible. Yeah.
Right. So this is our smart market platform. It's basically when you log in, you have this project structures similar to if you use Google Drive, you have different Excel sheets or different docs going on. We have the same concept of different projects. So for different use cases, you can create different projects. I'll dive into the demo project that I've built. This is just how the platform looks when you initially create a new project. On the left panel, we have the project, we have layers. Layers are basically data sets. Data sets, primarily, there are two types of data sets. There can be more, but the primary data set that we have, one is polygons, boundaries, basically regional boundaries. So whenever we do a new site selection exercise or expansion exercise, it starts at maybe a macro level. First, we might want to identify what are the towns or cities that I want to expand in. Once we identify the cities, we go a bit more granular and say what are the postal codes that I want to expand in. And then we keep going deeper into localities, and from localities, we go to the pinpoint location. So to make those decisions, we have boundaries globally, but here I'm catering the demo towards India. We start with like the most basic, when you turn on any layer, is our state boundaries. So we have boundaries for all states in India. Then comes like districts. So after state, we have district boundaries. Here, the district boundaries currently are color coded based on population. I'll just pull up a legend. So here is our district boundary, and it's showing which districts are highly populated, which districts are low populated. We have then tehsils, which are sub-districts. We go a layer deeper. We also have towns. So I was saying towns. So here I have pulled in all towns of one of India's biggest state, Uttar Pradesh. So these are all town boundaries in Uttar Pradesh. And then we also have village boundaries, which is sort of census defined the most granular level. So I'll be loading villages of Haryana. It will take a couple of seconds. It's just a heavy data set. While this villages of, yeah, so this is basically all village boundaries. And again, color coded based on population, where yellow is population over 10,000, green is population over 100,000. So this is just when I was saying at a very macro level, if I am a big bottler like Varun Beverages, what they do is on the map, they try to see what are those pockets, what are those towns that I should first target. And the most basic level information that they look for is population. I need people that I can serve. So population is first thing they look at. And this is villages of Haryana that I have here. We can go even deeper. So these are some layers that I preloaded beforehand. But our platform allows us to get any of these layers for any places. So let's say that pin codes, postal codes, I want to get for Delhi. I can just go here, query it, and here I'll get all the pin codes of Delhi. Each of my data layer comes with a lot of context and a lot of information. It's just not purely the boundaries. So like I was showing for district, along with my boundaries, I also get population. I also get what is the household count. We get other things such as what is the male count, what is the female count, working population, non-working population, what is the average income of each of these pin codes, what is the footfall, that is number of unique visitors that are going there for recreation purposes or to purchase retail, etc. So I can go here, and for any of these metrics, I can create a heat map and see how it distributes. I can go, and how I was talking about first level decision making, filter it. So on the map, I can see just what are those high populated pin codes in Delhi. And I can mix and match two filters together. So it is high population, and also want to understand what are the high footfall pin codes. So similarly, you can go deeper, 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 and try to understand. So these are pin code boundaries. And then finally, what we have at the most granular level, government defined boundaries, is locality boundaries. And these locality boundaries for Delhi go from locality, sub-locality, sub-sub-locality. So a locality might be a broader area. I know that we have people attending from all over the world, but I will give some Indian level context. So a locality is, let's say, this Vasant Kunj right here is a locality, and I'll just customize my tooltip so that we can see locality, sub-locality. So Vasant Kunj becomes my locality. Within Vasant Kunj, there are smaller sector, which becomes a sub-locality. And within those sectors, that there might be like gated societies or apartment complex, those become my sub-locality. So that's the concept of locality, sub-locality, and sub-locality. Here, the locality boundaries are actually color-coded by monthly household income. So the darker green shade you see implies that these areas have high income, and the red shade implies that these areas have low income. So this is, again, I'll pull up the gradient, and here we can see how the affluence what the legend is for what each color denotes. And this is really interesting because this gives us an insight more than just population. It gives us an insight about what might be the spending power of a person. And a lot of the brands, the products, they cater to different income level. Some cater to low income, some cater to mid income, some cater to high income. So this mixed match with other things becomes really powerful. And then how I was talking earlier, we have these regional boundaries. On top of that, we also have point of interest. So let's say I just want to view all ATM locations in Gurgaon. I can just click on the layer and all ATM locations come in. Here also we have multiple different ways to visualize it. So one is just a basic icon, but if I want to have a heat map, I can also have a heat map here. If I want to go into a cluster view, I can go into a cluster view. So it's just different visualization styles, and just visualizing things also sometimes gives you a lot of insights. What is happening? Seeing things on the map makes a big difference in just seeing things on an Excel. We also have a very interesting data set called new infrastructure projects. So these are all new infrastructure projects that are coming in a city, be it a big shopping mall, big apartment complex, big highway, big metro station. Really interesting data sets for companies to understand where the city is expanding. So like I was mentioning how visualization is powerful. If you just look at the map and within the city of Gurgaon, you want to understand where it is expanding, you can clearly see that on the outskirts is where it's expanding. This is the area where it's expanding, and there are a lot of different projects happening here. If I click on any of these projects, we get more information about it. We get what is the name of the promoter, the project name, expected completion date, the cost, and a lot of other metadata that helps you with better decision making. And then one more layer, petrol pumps. So it's one of the multiple different layers that we have. Again, if I go into styling, I have the name of the gas station, the petrol pump. So I can also color code it based on which brand it is. So if I just want to see the color coding depending on the brand, I can do that as well. So this is mainly talking about how I can use visualization. We still haven't gone into the analytics part of it. Now I'll move more into the analytics part of it, and I'll take a use case of, let's say I am a retail chain, I'm a fast food joint. These are my current 4 locations. 1, 2, 3, 4, 5. These are my current 5 locations. And the exercises that I'd like to expand within the state of Delhi, within the city of Delhi, I would like to expand, and I want to understand based on this platform what are the areas I should potentially expand to. So this is my uh, problem statement, right? So the first thing that we like to do is try to define a catchment area. What a catchment area means is that each store each store that I have is already covering an area. So we would like to define a catchment area. There are multiple different ways to define a catchment area. One is a simple buffer. So traditionally, this is how companies used to do earlier. FMCG companies actually used to print a big map and then have cups and actually draw the outline of what an outlet or distributor is covering. But now with technology, we can do things much better. So this is a simple buffer, a straight buffer. So this is, let's say, 5 kilometers is what the area it is covering. But we have advanced much more, and there are other ways. So one thing is drive distance catchment. What drive distance catchment means is that if I, from this point, drive in all directions, how far can I get in 5 kilometers? So this here is creating a drive distance catchment, and you see these drive distance catchment are much smaller in nature as compared to the 5 kilometer buffer. And then we also have something which is known as drive time catchment. And drive time catchment is how far can I travel in X minutes. So time becomes even better because distance and time don't correlate to each other in metropolitan cities. Where there is high traffic, even a 5 kilometer distance can take almost an hour. So here, when we see drive time catchment, we'll see in areas like here, Northeast Delhi, I believe, the catchments is much bigger than the central part or the southern part of Delhi where traffic is much more dense. So some companies nowadays prefer using drive time catchment instead of drive distance catchment. And these drive time catchments are actually built on top of real-time traffic data using Google Maps. So it considers traffic. It is also considering traffic. Where traffic is high, the catchments would automatically become smaller in size. So this is basically the first step where I define the area that I am currently covering. This is the area I'm currently covering. And again, opening, this is the area that I want to expand to. So this is the problem statement. First, what we'll do is we'll create grids. So grids is that I want to do my analysis on equivalent size grids, on 2 kilometer grids. All grids need to be the same size, and what my output would be exactly what are those grids where I potentially can open my next store. So we have these grids, we have these boundaries. In GIS, there is this simple functionality called difference. And this is basically a action panel where there are a lot of different analytic toolbox that you can use. I'll go over some of them. First is difference. So I have to take the difference between my drive time catchment. What this will do is that this will remove all those grids that fall within this catchment. So this is what we did. Now I have my catchments and I have the grids that I actually want to analyze. All the grids that I don't need have been removed. So this is my grid layer. Next, what I want to do is I want to start populating these grids with more information, with more content, with more GIS content. So our population data I was mentioning earlier, it's not just available at a pin code or locality level. It's actually available at a really granular level of 150 meters into 150 meters. So using our get demographic data for these 2 kilometer grids, I can start populating it with information. One is what is the population. The second is maybe I want to understand number of households. It's number household population. I want to understand what is the monthly household income. I want to understand what is the footfall of this area. So I'll just query all of this. I'll calculate the data, and in a couple of seconds, each of these grids would have population, monthly household income, and footfall. Again, I can go here and simply create a heat map. So first thing I want to understand maybe is where are the highest number of households, and we can see the households are much more higher here on the right side. Or I want to understand where income is higher. So income is higher here and somewhere here more south of Delhi. Where footfall is higher. Footfall is higher again central of Delhi and this side of Delhi as well. So this is all socio-economic demographic data that we fill these grids in with. But there is more to it. We can also fill in with infrastructure data, point of interest data. So how I was mentioning that we also utilize a lot of Google data. There is a new capability they've released called Places Insights that only Lepton currently has access to. What it does is it helps us to query point of interest data straight away from Google's database. So from Google's database, for any type of polygon, either these grids or pin codes and catchments, I can understand the count of different point of interest categories. So I can understand what is the count of fast food restaurants according to Google in these particular grids, or how many apartment complexes are present here, or how many malls are present here, or let's say how many banks are present here. So if I go through the categories, there are almost 200 categories here. Business, corporate offices, I can choose, pick and select what all I want. Education, we can pick school here. So just whatever is relevant to your problem statement, you can start picking up those categories. Now, once I've selected the categories for which I want count, next step is that you can then define certain filters to it. So one filter is that the business should be operational. It should not be temporarily closed or permanently closed. Second interesting thing is that we can also put filters on ratings. So that is that I want my point of interest, whatever the count comes out, all of them should be highly rated. So the rating should be more than 3. I'll remove the filter for now just to keep the count high. And we can also put filter on number of user ratings, which is sort of a proxy to popularity. So you can say that I don't want all point of interest counts. I only want count for popular point of interest. And for that, you can sort of put that these point of interest at least need 100 ratings or more. So this is one more filter that you can put. Then this is aggregate by, which mostly applies to restaurants, where when the count comes, you can split the count by do the restaurants offer delivery or do they not? Do they offer dine out or not? Do they serve breakfast or not? So this is really specific to the QSR and fast food industry. Then we can select if the category should be the primary category or it can be one of the additional categories. And finally, include aggregate counts. What include aggregate counts means that with the count of how many fast food restaurants there are in each grid, we will also get what is the total number of user ratings for all the fast food restaurants, and also what is the average rating. So now you'll see that we have many more attributes that we've collated for these grids. And similarly, I can go here and then I can say where are highest number of fast food restaurants. So we get this particular grid has 140 fast food restaurants, and this half broken grid has 115 fast food restaurants. But what if I go with reviews? Which fast food restaurants have highest number of reviews? So the gradient changes a bit, where this place right here has the highest number of reviews, which probably shows that the fast food restaurants here are more popular than the fast food restaurants here. There's a chance maybe it has a McDonald's and a Burger King and a Subway, which tends to have more higher user ratings. So this is how you can use the user ratings. Now, we'll see that for each grid, there are multiple things we have. We have fast food restaurants, count of apartment complex, shopping malls, banks, the population, the footfall, and many other things. Now, I want to sort of narrow down on what grids I actually want to, would be the grids that I focus upon, the grids that I actually make a decision to open my store in. We have a function called score weightage. What score does is that you can combine all of these multiple attributes that you bring on, that you enrich your grids with, into a single scoring function. So what you can do is that each of the attributes that might be relevant to your use case, you can come here and give it a score. So I'll say that I care about high household count. I care that monthly income should be high, so I'll give it a weight of 0.4. I also want that footfall should be high, so I'll give it 0.2. Then fast food restaurant count, since the use case I took was expansion of fast food restaurants, I'll give it a weight of 0.5. And similarly, you can keep going down. I'll just stop at these 4 attributes. I'll say calculate weight. And then we'll see a score gets calculated. So now I'll say that I want to create my heat map basis of score. We get a heat map where the score is highest. I can go here and start filtering and eventually land on that what are those, let's say, top 4 grids where I can open my next store. This is a recommendation that is coming out. These are the 4 places that currently I don't target, and these are the 4 places that I can go and open my store in. Now, within, let's say I pick up this particular grid and I want to understand more information. What all else can I get? I understand the count, but maybe there are more things to it that I can get. So I'll just clean this up a bit. So this is my grid. First, we have something known as traffic insights. What traffic insights helps you do is that for all the roads that are here, we actually have traffic data. So this becomes interesting when you are trying to make decisions at, do I open my store here or on the other side of the road? So you can actually go here, and I'll put this on the tooltip, understand what is traffic segmented basis on the time of the day and also daily average. So I'll see that traffic here on this segment, daily average is 1,000 cars. And on the other side of the road, it is much more, 20,000. But that's probably because this is a service lane and this is not a service lane. So let's pick up this. This is a service lane. So daily average of vehicular traffic is much lower this side than it is on this side. So this is one interesting insight that I can get basis on traffic data. And all the roads, be it a service lane, highway, 1 side, 2 side, everything is covered here in our traffic data. Once we have traffic data, we can get more information. I was showing earlier about how the counts of fast food restaurants, the counts for apartment complexes. What if I actually want to see the physical locations, want to understand which are the fast food restaurants? I can do the same. So I'll just select fast food restaurants for which I want the count, like we were doing additional types. We'll select what all we want from those fast food restaurants. So the phone number, the business status, the rating, the review, all of that we'll get. We'll call this function advanced area insights, which first will tell us basically the count, how many fast food places will be returned and how many credits it's going to charge. So 119 credits. And then I'll say continue. And in a couple of seconds, it would bring all fast food locations, physical locations of all fast food restaurants here. So more than count now, I actually know what are these restaurants. I can go by the name. I can see if there is a McDonald's, and I click on McDonald's, and I see there are two McDonald's here. I can see all the different restaurants, maybe a Taco Bell. I can differentiate it, which one's a branded restaurant, which one's not a branded restaurant. I can create a heat map here. I can say that I want to understand which ones are, one second, user rating count. Right, so this is basis of user rating count, where it's showing orange shade shows that high number of people have reviewed, and yellow is like low number of reviews. So I can filter it. That I just, how I was mentioning, I just want popular point of interest. I can go filter here, and then I can see these 1, 2, 3, 4, 5 are the high reviewed ones. I can see which fast food restaurants exactly they are. And then now I have more insights. It's just not the count, but actually knowing which brands are present there. And along the brands, I can see what potentially is the vehicular traffic in front of it, what potentially is the footfall. All of that can be done. So this is the use case around new site selection, how we started at what grids potentially we can target. And once we select one grid, we can start getting even more granular data about those grids. So this is one of the primary use cases that people use, and there are multiple other functionalities that are here. I didn't go over all of them. I'll just go over one more interesting functionality for since the main idea is optimization for distribution. I'll go over one more use case. So here what we have is a layer of all my current distributors. So let's say I'm a big FMCG company or a construction material company, and I have my two distributors here. And corresponding to those distributors, I have all outlets. What are all the outlets that I have? What you can do here is that you want to understand, if you want to understand which outlets should be tagged to which distributor, you can do that by using a function known as proximity analysis. What that does is that here you can go and say that I want for each of these outlets to get distance to my closest distributor. So you select.
Sorry, Umang, I quickly wanted to give you a check. We have only 10 minutes left, so you may want to.
I'll just go over this use
5
case.
minutes for Q&A as well. Sorry.
Right, I can select address, I can say aerial or drive distance. And then what will happen is that for each of my outlets, I would know that which one's my nearest distributor. I'll just color code it and show it how it looks. So these green ones basically are closest to here, and these purple ones, lightish purple ones, are closest to this particular distributor. So even if you want to do distributor outlet mapping, that's one more use case you can do with this. So I'll stop here. I think so. Yeah. I think so I'm done with the demo. If there are any questions, I'd be happy to answer. Okay, yeah.
So there are a few questions. Siddharth, do you want to go over them?
My apologies. We can go ahead with the questions as well. Let's start off with the questions. So the first question is, we often assume that high footfall or dense population guarantees success, but in your experience, which variables has surprisingly turned out to be the stronger predictor of store performance in a new location or in a predictive analysis?
Competition is a good predictor for retail. We did a project for IOCL. We tried to predict potential new locations and also where what would be the sales of petrol and diesel over the next 5 years. For that, one of the most important parameter was traffic, which is similar to footfall, but one more important parameter was upcoming infrastructures for the prediction of next 5 years, because that really guided if new factories are coming around that area, new malls, new schools are coming around the area, and if population would be growing. And that really helped us in the 5-year projection. So yeah, point of interest other than demographics and footfall is interesting. I think so we can take a question from Alexander, which is the third one. You can skip the second one.
Sure.
So
yeah, please go ahead.
So Alexander, yes. So there is a new solution that is coming out that we're releasing. It's called traffic management solution. It allows you to understand what are the traffic patterns throughout the day, what is the congestion score in an area, how can you optimize your traffic light signals. That is a new solution, and it would be available globally, worldwide. We just need to understand if you're representing a private company or a government agency, since this solution is primarily for traffic police agencies and government agencies that are into planning of roads and traffic lights, etc. There is a question from Rajat. Where and how smart market tool is taking various data? Right. So, like I said, it's a combination of Lepton's data. It's a combination of a lot of Google's data, and also a lot of partner. We have partner companies that provide us with the data set. We traditionally are a GIS company. We create content. We create content around maps. We have people that survey the whole country, get information such as different point of interest. In fact, we have been in the business of selling data for a really long time. Google, Apple, these are some of customers that buy data from us. So you might have seen on Google Maps road closures. It shows that a particular road is closed or there is an accident on the road. That data is provided by Lepton in real time. So it's a combination of our data, some from vendors and some from Google, but primarily it's our own data set that we've created over the years and data set from Google. Sajjad, we have catchments through walk time distance as well. Yep. We can create right now the catchments. So the question is, can we create walk time catchments, walk time and walk distance catchment? That is possible as well. Right now, I was just showing you drive distance catchment, but walkability becomes really important, especially in countries in Europe where people tend to walk much more. So yes, it is possible to create walk time and walk distance catchments. Please also include will you explain in brief how platform can be used for financial firms, especially who are into lending? So in lending, how we've helped banks is that based on the customer's location, that can be potential customer's location, we can provide a lot of information based on the area they live in. So if you provide us with an address, we can tell you what is the income of the address of the area they live in, how is the demographics of that area. We also help, like I was mentioning, insurance companies in setting premiums for housing basis on natural calamities, natural disasters. If a area is more prone to floods, if a area is more prone to earthquakes. So this is one of the use cases. And for agents, we have a field force tracking applications that can help you track your agents. It can help you create tickets for them. You can understand it helps you optimize the route that the agent has to take, check-ins, taking photos. So that is something that we have for on-field agents. Currently, Vodafone Idea is using it for almost 10,000 people that are on ground, going around daily, fixing breakages in the network or attending to customer complaints. So that is a potential solution you can use. Are there any customers leveraging the solution services to address needs of under? So Archita has a question. Customer leveraging the solution service to address the needs of underserved zones. I think so. When I was showing the demo, right, underserved zone for, let's say, similar to my use case where I had it for fast food restaurants. Currently, I gave weightage to population, I gave weightage to footfall, and I gave weightage to high number of fast food restaurants. But to see underserved zones, what potentially we can do is we will still give high weightage where areas have high population, where areas have high footfall, but we will remove the weightage for if a fast food restaurant is present. In fact, we will give high weightage to grids where fast food restaurants are not present. So this would help us identify for your particular industry where there are favorable attributes, but currently no one is present or none of your competition is present. So that is one of the ways where you can utilize location intelligence, and it both applies to India and internationally. Manish, do you have something to add on this? Hopefully, I was able to answer this correctly.
No, you're right, Umang. I think you have answered it correctly. So maybe we can quickly move on to the next question.
Yeah, can we integrate this software in Power BI? Yes, we can. We've integrated it with ClickSense and Power BI prior, and this can be integrated in any BI software. Can we get these details for deep rural areas? Yes, we can. We have data for Pan India. All of the data sets that we showed is available for Pan India. Mostly commercials in any distill are generally concentrated. So next by Akshay, can we know the traffic density of vehicles, mostly commercial vehicles concentration in any time of the day? We don't have bifurcation on basis of type of vehicle. We have traffic data. We just have the PCU count, that is total number of vehicles in a patch of road, divided by time of day. So at 6 hours intervals from 12 a.m. to 6 a.m., 6 a.m. to 12 p.m. and so on. But there is no bifurcation. It is just PCU number of vehicles. How will be next question? How far this will be useful for deep rural penetration? Right. I think so. It's really useful because for big areas, for established, for established industries, companies, they are now moving into tier 2, tier 3 cities, especially in India. As tier 2, tier 3 cities are growing, a lot of companies want to expand there. And if we know a lot of things already about Delhi NCR or Mumbai, we have macro level insights. But when we go to these smaller cities, we do not know a lot what's going on. In fact, when I was talking about even taking decision at macro level, this is where it really comes in. So Varun Beverages, they use our software not for like micro level planning, that pinpointing which location I should open it. Rather, they use it to see what are those towns and villages in Haryana where currently I have no penetration, where currently I'm not present. So just quickly going on how they do it, they have their distributors mapped in Haryana. They create a catchment, that is what villages I'm already covering. And then the villages that remain, they see what are those villages that have high population and what are those villages that can potentially stock their product. Since they're bottlers for Pepsi, they try to understand what are those, what villages have high number of POIs that can stock their product. And basis of that, they're able to decide what villages, what towns, what tier 2, tier 3 towns or small villages I should be targeting next.
So Umang, I think let's take one more, and then the rest of the questions we can answer them via email. There is one last question that how can we access your data sets or even the smart market platform? Do you want to take it up?
You can take it.
So after this call, we have an open website where you can actually go and test our data sets, APIs, and even the smart market platform. We will be sending out more details via email who all have registered for this webinar. So please keep a look on that. And yeah, and all the sorry about it. Any any questions which are unanswered at this moment, please allow us some time to get back to you separately on that.
All right, everyone. Thank you so much for joining for the webinar. Great. Thank you.
Thank you.
Thank you.